The McDonnell Douglas F-15 Eagle is an American twin-engine, all-weather tactical fighter designed by McDonnell Douglas to gain and maintain air supremacy in aerial combat. It is among the most successful modern fighters, with over 100 victories and no losses in aerial combat, with the majority of the kills by the Israel Air Force. Following reviews of proposals, the United States Air Force selected McDonnell Douglas design in 1967 to meet the service's need for a dedicated air superiority fighter. The Eagle first flew in July 1972, and entered service in 1976. The Eagle has since been exported to Israel, Japan, and Saudi Arabia, among other nations. The F-15 was originally envisioned as a pure air superiority aircraft. Its design included a secondary ground attack capability that was largely unused. The design proved flexible enough that an all-weather strike derivative, the F-15E Strike Eagle, was later developed, entering service in 1989. The F-15 Eagle is expected to be in service with the U.S. Air Force past 2025. Newer models are still being produced for foreign users. The F-15 production line is set to end in 2019, 47 years after the type's first flight. Development origins. The F-15 can ultimately trace its origins to the Vietnam War, when the U.S. Air Force and the U.S. Navy fought over tactical aircraft being used in the war. At the time, Defense Secretary Robert McNamara was pressing for both services to use as many common aircraft as possible, even if there were performance sacrifices involved. As part of this policy, the USAF and Navy were involved in the TFX program, aiming to deliver a medium-range interdiction aircraft in Air Force use that would also serve as a long-range interceptor aircraft for the Navy. In January 1965, Secretary McNamara asked the Air Force to consider a new low-cost tactical fighter design for short-range roles and close air support to replace several types like the F-100 Super Sabre and various light bombers then in service. Two basic designs could fill this role. The Navy favored designs like the Douglas A-4 Skyhawk and LTV A-7 Corsair II, pure attack aircraft, while the Air Force was more interested in fighter bombers like the Northrop F-5, fighters with a secondary attack capability. The former were more capable in the tactical role, while the latter might be less so but could defend themselves. If the Air Force did choose an attack design, maintaining air superiority would be a top priority. The next month, a report on light tactical aircraft suggested the Air Force purchase the F-5 or A-7, and consider a new higher performance aircraft to ensure its air superiority. This point was driven home after the loss of two Republic F-105 Thunderchief aircraft to obsolete MiG-15s or MiG-17s on 4 April 1965. These early studies envisioned a production run of 800 to 1,000 aircraft, and stressed maneuverability over speed. It also stated that the aircraft would not be considered without some level of ground attack capability. On 1 August, Gabriel de Sosway took command of Tactical Air Command and reiterated calls for the FX, but lowered the required performance from Mach 3 to 2.5 to lower costs. Ultimately, the Air Force chose the A-7 over the F-5 for the support role on 5 November 1965, giving further impetus for an air superiority design as the A-7 lacked any credible air-to-air capability. An official requirements document was finalized in October, and sent out as a request for proposals to 13 companies on 8 December 1965. 8 companies responded with proposals. Following a down-select, 4 companies were asked to provide further developments. In total, they developed some 500 design concepts. Typical designs featured variable sweep wings, weighed over 60,000 pounds, included a top speed of Mach 2.7 and a thrust-to-weight ratio of 0.75. When the proposals were studied in July 1966, the aircraft were roughly the size and weight of the TFX. Unlike that aircraft, a design that could not be considered an air superiority fighter. Smaller, lighter. Through this period, studies of combat over Vietnam were producing worrying results. Previous doctrine had stressed long-range combat using missiles, and optimized aircraft for this role. The result was highly loaded aircraft with large radars and excellent speed, but limited maneuverability and often lacking a gun. The canonical example was the McDonnell Douglas F-4 Phantom II, used by the USAF, U.S. Navy and U.S. Marine Corps to provide air superiority over Vietnam, the only fighter with enough power, range, and maneuverability to be given the primary task of dealing with the threat of Soviet fighters while flying with visual engagement rules. In practice, both due to policy and practical reasons, aircraft were closing to visual range and maneuvering, placing the larger U.S. aircraft at a disadvantage to the much less expensive day fighters like the MiG-21. Moreover, missiles proved to be much less reliable than predicted, especially in close-range combat. Although improved training and the introduction of the M61 Vulcan cannon did much to address the disparity, these early outcomes led to considerable re-evaluation of the 1963 Project Forecast doctrine. This led to John Boyd's energy maneuverability theory, which stressed that extra power and maneuverability were key aspects of a successful fighter design, and these were more important than outright speed. Through tireless championing of the concepts, and good timing with the failure of the initial FX project, the fighter mafia pressed for a lightweight day fighter that could be built and operated in large numbers in order to ensure air superiority. In early 1967, they proposed that the ideal design had a thrust-to-weight ratio of near 1:1, a maximum speed further reduced to Mach 2.3, a weight of 40,000 pounds and a wing loading of 80 pounds-feet squared. By this time, the Navy had decided the F-111 would not meet their requirements, and began development of a new dedicated fighter design, the VFAX program. In May 1966, McNamara again asked the forces to study the designs and see if the VFAX would meet the Air Force's FX needs. The resulting studies took 18 months, and concluded that the desired features were too different. The Navy stressed loiter time and mission flexibility, while the Air Force was now looking primarily for maneuverability. Focus on air superiority. In 1967, the Soviet Union revealed the MiG-25 Fox-8 at the Domodedovo airfield near Moscow. The MiG-25 was designed as a high-speed, high-altitude interceptor aircraft, and made many performance trade-offs to excel in this role. Among these was the requirement for very high speed, over Mach 2.8, which demanded the use of stainless steel instead of aluminum in many locations on the aircraft. The added weight demanded a much larger wing to allow the aircraft to operate at the required high altitudes. However, to observers, it appeared outwardly similar to the very large FX studies, an aircraft with high speed and a large wing offering high maneuverability, leading to serious concerns throughout the Department of Defense and the various arms that the U.S. was being outclassed. The MiG-23 was likewise a subject of concern, and it was generally believed this was a better aircraft than the F-4. The FX would outclass the MiG-23, but now it appeared that MiG-25 would be superior in speed, ceiling and endurance to all existing U.S. fighters, even the FX. Thus, an effort to improve the FX followed. Both Headquarters USAF and the TAC continued to call for a multi-purpose aircraft, while both DeSosway and Air Chief of Staff Bruce K. Holloway pressed for a pure air superiority design that would be able to meet the expected performance of the MiG-25. During the same period, the Navy had ended its VFAX program and instead accepted a proposal from Grumman Aircraft for a smaller and more maneuverable design known as VFX. VFX was considerably closer to the evolving FX requirements. The Air Force infighting eventually ended by the worry that the Navy's VFAX would be forced on them. In May 1968 it was stated that, "We finally decided, and I hope there is no one who still disagrees, that this aircraft is going to be an air superiority fighter." In August 1968 a new SRP was prepared. The new requirements called for single-seat fighter having a maximum takeoff weight of 40,000 pounds for the air-to-air roll with a maximum speed of Mach 2.5 and a thrust-to-weight ratio of nearly 1:1 at mission weight. It also called for a twin-engine arrangement as it was believed this would respond to throttle changes more rapidly, and might offer commonality with the Navy's VFX program. However, details of the avionics were left largely undefined, as it was not clear whether to build a larger aircraft with a powerful radar that could detect the enemy at longer ranges, or alternately a smaller aircraft that would make it more difficult for the enemy to detect it. 4 companies submitted proposals, with the Air Force eliminating General Dynamics and awarding contracts to Fairchild Republic, North American Rockwell, and McDonnell Douglas for the definition phase in December 1968. The companies submitted technical proposals by June 1969. The Air Force announced the selection of McDonnell Douglas on 23 December 1969. The winning design resembled the twin-tailed F-14, but with fixed wings. Both designs were based on configurations studied in wind tunnel testing by NASA. The Eagle's initial versions were the F-15 single-seat variant and F-15 twin-seat variant. These versions would be powered by new Pratt & Whitney F-100 engines to achieve a combat thrust-to-weight ratio in excess of 1:1. A proposed 25mm Ford Philco GAU-7 cannon with caseless ammunition suffered development problems. It was dropped in favor of the standard M61 Vulcan gun. The F-15 used conformal carriage of 4 Sparrow missiles like the Phantom. The fixed wing was put onto a flat, wide fuselage that also provided an effective lifting surface. The first F-15A flight was made on 27 July 1972 with the first flight of the 2-seat F-15B following in July 1973. The F-15 has a look-down, shoot-down radar that can distinguish low-flying moving targets from ground clutter. The F-15 would use computer technology with new controls and displays to lower pilot workload and require only one pilot to save weight. Unlike the F-14 or F-4, the F-15 has only a single canopy frame with clear vision forward. The USAF introduced the F-15 as the first dedicated USAF air superiority fighter since the North American F-86 Sabre. The F-15 was favored by customers such as the Israel and Japan Air Arms. Criticism from the fighter mafia that the F-15 was too large to be a dedicated dogfighter, and too expensive to procure in large numbers, led to the lightweight fighter program, which led to the USAF General Dynamics F-16 Fighting Falcon and the middleweight Navy McDonnell Douglas F/A-18 Hornet. Further development: the single-seat F-15C and two-seat F-15D models entered production in 1978 and conducted their first flights in February and June of that year. These models were fitted with the production Eagle package, which included 2,000 pounds of additional internal fuel, provisions for exterior conformal fuel tanks, and an increased maximum takeoff weight of up to 68,000 pounds. The increased takeoff weight allows internal fuel, a full weapons load, conformal fuel tanks, and 3 external fuel tanks to be carried. The APG-63 radar uses a programmable signal processor, enabling the radar to be reprogrammable for additional purposes such as the addition of new armaments and equipment. The PSP was the first of its kind in the world, and the upgraded APG-63 radar was the first radar to use it. Other improvements included strengthened landing gear, a new digital central computer, and an overload warning system, which allows the pilot to fly up to 9 grams at all weights. The F-15 multi-stage improvement program was initiated in February 1983 with the first production MSIP F-15C produced in 1985. Improvements included an upgraded central computer, a programmable armament control set, allowing for advanced versions of the AIM-7, AIM-9, and AIM-120A missiles, and an expanded tactical electronic warfare system that provides improvements to the ALR-56C radar warning receiver and ALQ-135 countermeasure set. The final 43 F-15Cs included the Hughes APG-70 radar developed for the F-15E. These are sometimes referred as enhanced Eagles. Earlier MSIP F-15Cs with the APG-63 were upgraded to the APG-631 to improve maintainability and to perform similar to the APG-70. Existing F-15s were retrofitted with these improvements. In 1979, McDonnell Douglas, an F-15 radar manufacturer, Hughes, teamed to privately develop a strike fighter version of the F-15. This version competed in the Air Force's dual-role fighter competition starting in 1982. The Boeing F-15E strike variant was selected for production over General Dynamics' competing F-16XL in 1984. Beginning in 1985, F-15C and D models were equipped with the improved P&W F-100-220 engine and digital engine controls, providing quicker throttle response, reduced wear, and lower fuel consumption. Starting in 1997, original F-100-100 engines were upgraded to a similar configuration with the designation F-100-220E starting. Beginning in 2007, 178 USAF F-15Cs were retrofitted with the AN APG-633 active electronically scanned array radar. A significant number of F-15s are to be equipped with the joint helmet-mounted cueing system. Lockheed Martin is working on an IRST system for the F-15C. A follow-on upgrade called the Eagle Passive Active Warning Survivability System was planned but remained unfunded. Boeing was selected in October 2015 to serve as prime contractor for the EPA-WSS, with BAE Systems selected as subcontractor. The EPA-WSS is an all-digital system with advanced electronic countermeasures, radar warning, and increased chaff and flare capabilities in a smaller footprint than the 1980s-era tactical electronic warfare system. More than 400 F-15Cs and F-15s will have the system installed. In September 2015, Boeing unveiled its 2040C Eagle upgrade, designed to keep the F-15 relevant through 2040. Seen as a necessity because of the low numbers of F-22s procured, the upgrade builds upon the company's F-15SE Silent Eagle concept with low observable features. Most improvements focus on lethality, including quad-pack munitions racks to double its missile load to 16, conformal fuel tanks for extended range, Talon H communications pod to communicate with fifth-generation fighters, the APG-633 AESA radar, a long-range infrared search and track sensor, and Northrop Grumman's Eagle Passive Active Warning Survivability Systems.